Hello everyone, welcome to this video on logistic regression. In our last video, we covered the linear regression algorithm where the goal was to predict the continuous values by drawing a straight prediction line. But what if we need to predict categorical values instead of numbers? That's where logistic regression steps in. At first step, the name might trick you into thinking it's related to linear regression. But in reality, logistic regression is totally different. It's designed to classify things into distinct groups. If you have understood linear regression, this concept is going to be a no-brainer for you. Let's try to understand it with a simple intuitive example. Imagine you're working for a bank and you need to build a system that predicts whether a customer will default on a loan or not. The data you have includes the income of a customer, his age, and loan default status. Here, the loan default column is what we are trying to predict, which contains values like yes or no, which means a target variable is categorical, not continuous like before. So, if we draw a straight line, we'll get a terrible classifier. But what if we draw a shape like this? This S shape seems to do really well, right? This is what is called as the sigmoid curve, and this is the equation that helps us achieve it. Right now, it looks bizarre, but don't worry. Just understand that this predictor classifies things in binary class, either 0 or 1. And in this particular example, if the data points lies above 0.5, we classify it as yes, and if it's less than 0.5, we classify it as no. This is something that you'll clearly understand by the end of this particular video. And to make sure you never have to struggle with logistic regression again, let me hand over the further proceedings to one of our leading data scientist trainers. By the time he's done teaching, logistic regression will be second nature to you. Let's dive right in.
Before I jump into logistic regression, I have a question I want to ask. My questions can be more of a brain fry, but I promise you, if I fry your brain now, you will thank me later. Can I do that? Since you've already learned linear regression and logistic regression, have you ever encountered a problem where I wanted to classify a problem? For example, you give me the input data and I will classify whether this item is belonging to category A or category B. Isn't this what we call classification? Have you ever heard of something called multi-label classification and multi-class classification? One of the most interviewed question. Do you know that classification also is of two different types? One classification is called multi-label classification and the other is called multi-class classification. Did you know this? Imagine you have a category, okay? Things like love, hate. You tell me the name of the movie and I will predict whether people love the movie, hate the movie, or don't know the movie. So tell me one thing. How many categories do I have of classification? Three, right? Number one, number two, number three. These are called categories, right? So-called buckets. What if my problem statement is under love, also there are two categories. Really love it? Okay, love it. Did I make the problem statement more complicated? First, you predicted whether you love it. Under love, do you really love it or not that much love it? In real life scenarios, have you not seen that this is more predominant? When you have a classification problem called you love some movie, under love, is it not possible that you can really have another category between them? But in logistic regression, you only know it is a classification problem. That is very good in theory. What in practical life, if you want to implement something like this, will you be able to do with logistic regression? Imagine you give me your age, you give me how much salary you make and what is your CIBIL score. And I will tell you either you are a high risk person, low risk person, or moderate risk person. Is this a classification problem or regression problem? Is this a classification problem or regression problem? Classification problem? Okay. Under high, if I want to predict that you are a very high performer or moderately high performance, under low, very low, moderately low, and under moderate, you just say moderate. This is the problem statement. When I predict, given your age, your salary, and CIBIL, first I want you to tell me which category I belong into. And in that category, I want you to tell me which subcategory do I belong into. Acha, tell me one thing. Whatever I've told you, isn't it very practical in real life? This must happen. Whenever people are doing classification, they must be going through this problem. Okay. My question to you is, you guys know logistic regression a little bit. Do you think this is possible using logistic regression? This problem? Can you keep this question on the top of your head for about a second until I introduce the topic and then we will talk about it? So my people, from calculating continuous values, I take you to another topic called logistic regression. Now, let me tell you, do not underestimate the topic of logistic regression. Logistic regression is going to become your foundation for learning very complicated algorithms like naive-Bayes classifier, k-nearest neighbor, decision trees, and random forests. If you don't understand logistic regression really well, you will not be able to learn naive-Bayes classifier, k-nearest neighbor, you'll not be able to understand random forest, and you'll not be able to understand decision trees. And if you don't understand decision trees and random forest, you will not be able to learn an algorithm called XGBoost. So everything is connected. Everything is like a dot by dot connection. So you need to learn the topic of logistic regression. And what I'm going to do is I'm going to take you guys through a journey which will be a little mathematical in nature, but also important for you to understand it theory-wise. What concept did you learn in logistic regression? Okay, let me ask and you tell me yes and no. Did you learn the concept of log of odds? Did you learn the concept of maximum likelihood estimation? Did you learn log of odds only on the top level or did you go deeper? Okay. What about maximum likelihood estimation? Was this concept introduced? Maximum likelihood estimation. Okay. Did you also learn the concept of sigmoid? Were these three topics introduced? Okay. 1 by 1 plus e to the power of minus x. Remember? You guys know the concept of 1 by 1 plus e to the power of minus x? Okay. So tell me one thing. If I ask you how the data comes, what steps happen and how you get the output, will you be able to tell me what will be step number 1, what will be step number 2, what will be step number 3? Do you know at that much level, this much level of clarity? Okay. Tell me one thing. When we do linear regression, we fit a line. But does the line go beyond infinity? And this line can also go beyond positive infinity and negative infinity? ये possible है? 100% it is possible. Line का कोई अंत ही नहीं होता. Line has no end. Whenever you do logistic regression, you want to give a probability as an output, right? For example, you have a category called cat and dog. Whenever I input an image, don't you think I will get something called probability like cat is 92% probability and this is 8% probability. But always the probability of cat and dog together add up to 100. They don't go beyond 100. Whenever you do classification, unlike linear regression, where the line can extend up to positive infinity and negative infinity, in classification, we don't have the luxury to do that. Numbers cannot go beyond positive infinity and negative infinity. They need to be probabilities. And guess what? The probability of a cat and the probability of a dog, all the probability should add up to 100%. Let me give you one more example. If your output was, are you possibility of a high input person, low input person, or moderate input person? Suppose if the probability, I have a given person's data, I pass it through my algorithm, the probability is 92% high, 6% low, and 2% mode. You see, no matter how many categories you have, the probability for one input, the one input that you've passed, you always have a probabilistic output in the output. And whichever has the highest probability, 92%, that is my output. For the given input, my output is, yes, the person is a high performer. Even though low has some percentage more, moderate has some percentage, but because high had 92%, my output of this classification is high. Did you learn the difference between linear regression and logistic regression? Linear regression is a continuous value. Logistic regression is a probability value. Do you know what happens in logistic regression? Because when we have an equation like this, or when we have a data like this, we want the data or we want the output to be between 0 and 1. Yes or no? 0 means 0 probability. 1 means 100% probability. The reason we get this output is because we have a function in mathematics called sigmoid. What do we call this function? It's called logit function or sigmoid function. What it does mathematically is, no matter how big number you give it, it will convert the number between 0 and 1. Did you get it? You want to feed it 1,60,048 something rupees. No matter how big of a number you give, it will always convert that number between 0 and 1. Did you now understand why we choose sigmoid function? We want to bring down every data between 0 and 1. Got the concept between why linear regression and logistic regression is not preferred? But let me tell you an example and then we will understand. Let's take this example. Okay. You have a data 0 and 1. Okay. You have a data 0 and 1. Okay. I'm thinking of a good example for you. Is logistic regression a supervised learning or unsupervised learning? Is it a supervised learning algorithm or unsupervised? You guys already know that supervised learning means the data is labeled. Yes or no? What do you mean by labeled data? You have a column A, you have a column B. The column C will be the answer is labeled 0 or 1. 0 or 1. Yes or no? This is how the label is. This is your target variable C. This is your independent variable A and B, predictor variables. You have a label 0 and 1. In machine learning, you are only going to be given two kinds of data. Listen to me very carefully and everything will make sense. Imagine you work for a finance company like mine. Okay. Let's say you work in a finance company. Okay. You want to predict whether the person should be given loan or not. Is this a classification problem or regression problem? You just want to predict whether the person should be given loan or not. Isn't this a classification problem? Yes or no? So what do? We take the person's age because age matter करता है, right? Your age matters. अगर आप 70 साल के लोन तो नहीं दे सकता मैं आपको. Age will matter. Okay. आपका CIBIL score will matter. Higher the CIBIL score, better is the chance you will pay the money back. How much money you make? What is your salary per month? Which company do you work for? Make sense? Based on all these variables, I will predict whether the person should be given loan. Give loan, LOAN, loan. Answer is yes or no. No and yes. Imagine my age is 23. My CIBIL is 600. Okay. My salary is 15,000 per month. And my company is some XYZ company. I will say no. You will not be given loan. Imagine my age is 40. My CIBIL score is 875. My per month salary is 1,50,000 and I work for say Google example. Yes, I will give you a loan. एक बात बताओ, and I want age, CIBIL, salary, company. They all are helping you to predict something, yes or no? To predict whether you will give somebody loan or not. Labeled data का मतलब होता है, labeled data meaning your independent variables like age, CIBIL, salary, company, all are helping you to predict whether the person will be given loan or not. This is called labeled data. Label meaning you always have a target variable. Have a target variable. अगर मैं ये target variable को ही delete कर देता हूं, is this data labeled or not labeled? कोई label ही नहीं है. There is no more label. I just have age, CIBIL, salary, and company. This is called not a labeled data. Remember one thing. Whenever your data is not labeled, you will always use clustering algorithms here. Problem state in learning where you have no label. Do you know what you can do with that data? Nothing. Only and only clustering. That is the only solution to that data. Whenever you have label, you can run regression, you can run classification. But if you don't have label, it becomes unsupervised. It means you need to do clustering. Does that make sense? Sir, how will you decide a company weight to decide whether the company should be given a preference or not. Have you heard of a concept called encoding in machine learning? You have not heard the concept of encoding? Okay. What if Google, Amazon, Meta, and Adobe, all these companies get a label 1? So suppose every company that is a good company gets a label 1. Every company that my bank does not recognize gets a label 0. Did I give machine learning a value mathematical saying that 1 means it's a company that we prefer. 0 means it's a company we don't know, we don't prefer. Did you just encode the information? This is not one hot encoding. This is label encoding. But did you just encode the information? How machine learning solves problem? Does machine learning understand 15,000? Yes, it does. It's a number. Machine understands numbers. But does machine understand age 20? Yeah. Does machine understand the word path? It won't. Rudra, no. Joseph, no. Anubu, no. You need to convert that. So you have to follow something called encoding. Okay. Imagine I have a problem statement where the data is labeled, okay? And I have data between 0 to 1. Suppose I have some data points here and some data points here. Now tell me one thing. Is it possible to fit a line here in linear regression? No, it's not possible for you to fit a line, right? It's not possible because the problem is I want my data to be clipped between 0 and 1. But linear regression takes me beyond 1 and lesser than 0. Do you know what logistic regression has in its backend, in its engine, in its hood? It's a very simple concept. My people, when you have a data between 0 and 1, your data labels between 0 and 1, the problem statement with this is you need to account for all the data between your left and your round. You need to account all the data. You just can't encounter one data to the top, one data to the left and fit a logistic regression curve because the problem statement is this logistic regression curve the best? Is this logistic regression the best? Which curve is the best? You don't know. You don't know that problem. So I'm going to give you a slight idea just, and I will make a lot of sense into it. Okay. I promise. What logistic regression does, whenever your data comes, whenever your data has arrived, it will first put your data between the label of 0 and 1. Tell me one thing. This above example, have we not labeled the person that whether this person will get a loan, yes and no? Yes means 1, no means 0. Now that the concept 0 and 1 is given to me, right? I have segregated my data, yes or no? I have put my data. My people, you know what we do? Once this data is given to us, you know what I do? I apply a concept called log of odds. Now listen to me carefully. It will be a little confusing. I apply something called log of odds. What it does is it will convert this data that is between 0 and 1, and it will convert and make this data go between positive infinity and negative infinity. And your data will go here and your data will go here. And you actually fit a line. Do you see this part? You had a probability distribution data. You applied something called log of odds. It became negative infinity and positive infinity. And you are actually trying to fit a line. Now you must be very confused. Why are we doing this? Right? We already have a number between 0 and 1. Why do we need to convert our data into a negative infinity and a positive infinity value? And we are trying to fit the line. I have a small question to ask you. Just listen to me. In regression, what is the best thing about regression, linear regression? Linear regression tells me, is this line better? Is this line better? Or is this line better? Yes or no? Basically, the concept of linear regression tells me which line fits best. Yes or no? Imagine I take a data that is between 0 and 1, convert it between positive infinity and negative infinity. Suppose my data is here in the positive infinity. My data is here in the negative infinity. Can't I draw a line, drop all the points to the line and make some judgment later that from this line is better? For example, line number 1 in green and line number 1 in red. Which line is better? I can make a judgment. Don't worry how. We'll talk the how later. Just think, imagine, listen to me very carefully. My data is in positive infinity and negative infinity. I have two lines. One is green line, other is red line. Can I not drop all my data points on the red lines and green lines and make a judgment that maybe line 1 and line 2 does a better job? Can I not make that guess? After I decide between line 1 and line 2, which line is best, and I drop all the points, can I not apply something called sigmoid function, which is to this data, I applied the logistic regression 1 by 1 plus c to the power of minus x, and I will get 0 and 1 output again. The value is between 0 or 1 again. And this is the entire operation of my logistic regression. And we will learn everything in depth. Just giving you guys a hint, subtle hint. Are you understanding the overall perspective of logistic regression? Only 4 steps are performed. Data is given to us, is converted between 0 and 1. We convert that data between positive infinity and negative infinity using log of odds. Via log of odds, we fit a line. Whichever line is best, we apply sigmoid function to it and we get the output between probabilities. You kind of got a subtle hint. What steps are involved? Once the data comes, you actually apply something called log of odds. On log of odds, you apply something called sigmoid, and then you get a probability value. With the chain of process, what happens? Okay. Imagine, I tell you there is a fruit in the world called fluorobomba. Have you ever tried this fruit? Fluorobomba. The reason you have not eaten this fruit is because this fruit does not exist. I just made up the word. But did I give you an idea that there could be a word like this that could be a fruit? My point is, I know you did not understand what is log of odds, what is sigmoid. Ignore that. Can I at least tell you what the fruit tastes like and you can get an idea? I know you've not eaten the fruit yet, but if I explain at least 5%, you'll have an idea. What is the fruit? It is sweet. Is it sour? Is it huge? How do you cut it? Are you understanding what I'm trying to say? Point number 1. Did you get the process of what logistic regression steps are? Step number 1, you get the data. Step number 2, you apply log of odds. After log of odds, you need to convert it back again into probabilities. Hence, you apply something called sigmoid functions. Actually, you apply something called maximum likelihood. And after that, you get the output. So step is clear. Now, let's go in depth. Now, let's try to understand in depth how this particular thing works. Okay. Before I do that, did you learn the difference between probability and odds? Do you want me to reiterate it once or should I proceed forward? Listen to me very carefully and look at this problem statement, okay? A guy went fishing 5 times a week. How many times did he go fishing? 5 times in 1 week. Remember this number, 5 times in 1 week. He caught fish twice and he failed to catch 3 times. Okay. He caught fish twice. So twice he got success and thrice he got failure. This is the data, the current situation, the scenario. Probability is how many times did he get success divided by total times. So 2 times he caught the fish divided by how many times did he actually go out for fishing? 2 by 5. What is 2 divided by 5? What is 2 divided by 5? 40% success ratio, right? Can I say that this guy had a 40% success ratio? Every time he went for a fishing, the chances, the probability that he will get a fish or catch a fish is 40%. Have you heard in English, what are the odds of that? In English, you must have heard of this question. Hey, what are the odds of that? You encounter a problem. Suppose you are going into a, you're walking in a mall, you encounter or you meet your friend who you've not met after 5 years. Your first thought is, hey, what are the odds, right? Like, what is the odd you met me now? Listen, the concept of odd is different than the concept of probability. Odd is not the success of total event. Odds are 2 divided by 3. It means it is not the total time. It is the success by the total failure. And odds are higher than probabilities. So what is 2 divided by 3? What would be 2 divided by 3 in percentage? 60%, approximately, higher than that. That whenever you do probability, you divide it by the total values inside it. But odds don't happen like that. It is your success by your failures. which is called P by 1 minus P. Listen to me carefully. You got 90% in your marks. You got 90% marks in your 10th standard. What did you fail to get? Isn't it 100% minus 90%? The 10% you did not get? Am I now making sense? 100% may say it. 1 minus P, matlab 100% can also be called as 1. So it is called P divided by 1 minus P, success by failure. That makes sense to everybody? Let me ask you one more question. I just want to get a clarity. Imagine there is a ball. Imagine there is a bag. In this bag, you can't see the bag. There are 2 red balls, 3 black balls, and 4 green balls. Have you heard of something called conditional probability? Let me explain. Everything will become clear. If I remove one red ball, 2 black balls, and 1 green ball, what is the probability of getting the red ball? Can somebody tell me the answer to this? It will be how much? It will be 1 divided by 5, yes or no? Because only one red ball exists among all 5. Did you even consider the one that are not in the bag anymore? Did you not divide the whole category by the total data? Did you now understand? Any kind of probability, you always divide by what is left with you, total what is left with you. But odds don't work like that. Now that you have understood the concept of conditional probabilities, okay, let me tell you, why do we apply log? You must have heard of this thing called odds. I just taught you odds. But why do you need to apply log, 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 log? Have you ever heard of, encountered a word called logarithms in your mathematics ever? Let's break it down. What are logarithms according to you? Yeah. This is better. Okay. Let me also take this because ये भी सही ही है and paste it. Yeah. Guys, can I say that 2 to the power of 8, or hold on, what is 2 to the power of 3? Can I say 2 to the power of 3 is 8? 2 to the 4, 4 to the 8, which is basically 2 to the power of 3. Can I not write this equation as 2 to the power of 3 equals to 8 as log to the base 2 of 8 is equal to 2 is equal to 3? Am I making sense? Based on the given definition that I just showed you, logarithm helps us identify the power, right? The power x, the exponent, what we called as. Logarithms help us identify the calculations of exponents quicker than any other mathematical function. Can I also tell you something? Logarithms also have a base of natural logarithm e, or a natural base 2, or a natural base 10. Have you ever heard of this? Log to the base e, log to the base 2, log to the base 10. Okay. Now look, e is called Euler's constant. Okay. Euler's constant. It is 2.7 something something. I don't want to get into it. Okay. My people, what logarithm does, let me tell you something. Logarithm is a clipping function. What function is it? Clipping function. If you are suddenly increasing, I will make your increment like this. Imagine it like this. You are a very excited person. What logarithm would do is, it will make you less excited. It doesn't ask you to curb your enthusiasm. It will say, let your enthusiasm go over a period of time. Somebody whose growth has been happened exponentially, the opposite of exponents is logarithm, right? So it will ask that person to go steadily but more longer. Do you see that increment here is shorter, but the increment here is longer, but both are increasing? So the data is not lost, but it's just that it is expanded like a clipper. Making sense to some extent mathematically? Let's do this. Does y is equal to mx plus c happen for line equation? Is this called a line equation? When the number of variables are higher, suppose there is a column called age and column called salary, and I want to predict something like loan amount. Example. So can I say that age and salary is another variable? So I can say y is equal to m1x1 plus m2x2 plus c. Or you can call it m1 into age plus m2 into salary plus c. Can I call this as the line equation to solve this problem? This is mathematical way. If you talk from a mathematical visual way, it means that there are three equations, right? This is my loan amount. This is my age. This is my salary. So there will be a line rather than two dimension. Let's make it one dimension. So can I say that I can, whatever value of X I have, I drop that value of X on this line and the corresponding value of Y is my prediction, Y hat. I change the line, I take the value of X, plot it on the line, and whatever is on the Y is my prediction. So listen to me carefully. What is the equation of logistic regression? It is 1 by 1 plus e to the power of minus z. Yes or no? This is logistic regression. Yes or no? Do you know what is this z, guys? What is this z? What is this z? This z is nothing but, imagine you want to do logistic regression problem where you have age, you have salary, and you want to predict whether somebody will be given loan or not. LOA and loan. So suppose my age is 23. My salary is 1,50,000. Should you give loan? Yes. My age is 45 or 40. 15,000 is my salary. Should you give a loan? No. This minus z is nothing but g of x is equal to 1 by 1 plus e to the power of minus of m1 into age plus m2 into salary plus c. That's it. You're done. Plus c. This is what a logistic regression will be like. That line equation I told you that we are going to fit in positive and negative infinity, right? That line you just have to simply put here. Now, whichever value you will put, logistic regression will convert that between 0 and 1. See, guys, logistic regression is not very complicated. Okay, I'm just telling you guys an idea. It's not very complicated. How we get this equation is log of probability of x divided by 1 minus probability of x is equal to mx plus c. This is the core equation of logistic regression. When you do mathematical, movement and change it and all of that, you arrive at this equation. That is why. Does it not look like logistic regression? One sigmoid function 1 by 1 plus e to the power of minus x. Your z is nothing but the line equation that you're trying to solve. And if you apply the value, you'll get the output. Can I tell you some more idea? The value, how do you get the coefficient m1 and m2? You cannot use ordinary least square here. Can you? Suppose there is a line equation. Can you use ordinary least square here? No. Remember one thing, my people. To calculate the coefficient on M1 and M2, you use a technique called maximum likelihood estimation. Did you get the idea? In ordinary least square method, we calculated the value of M and C. In logistic regression, because we also fit a line, but this time we fit a line on a sigmoid, we calculate M1, M2, and C using a method called maximum likelihood estimation. If I write down a formula, if I write down the variable, can you write the equation for me? Imagine I want to take, imagine I have a data called area of the house, low height, low ground clearance, okay? Ground clearance, low ground clearance, longer body, and 3000 cc, greater than 3000 cc or not. Probability that this is a supercar. Can you write the logistic regression equation for this particular example? Can you write the logistic equation for this? The logistic regression equation for this? 1 by 1 plus e to the power of minus of whatever you want to write. I want the answer. Did you guys know how to write the sigmoid equation? 1 by 1 plus e to the power of minus of m1 into low ground clearance plus m2 into longer body plus m3 into greater than 3000 cc plus c. Did you all write the same equation? Did you now get it? It is that simple. That's it. You take a line equation, you convert the line equation. Boss, listen to me very carefully, people. When this is how our data looks like in logistic regression, all I'm doing is taking this logistic regression line, this linear line, and converting it into a squiggle. That's all I am doing. And I am doing this using the help of this function. That is it. आप अगर mathematically also if you code this up, you only need one equation and that is this much. Done. To calculate M1, M2, M3, C, you cannot use ordinary least square. You have to use a method called maximum likelihood estimation. Linear regression. Acha, tell me one thing. According to you, which is one of the most important library in Python? Import NumPy as NP. Import pandas as PD. Yes or no? Import matplotlib.pyplot as PLT. Okay, pyplot as PLT. See, these three libraries to boss are needed. Told you there are two kinds of data, right? Weekly data and sales data, right? So week underscore data and sales data. Sales underscore data. We had a weekly data like first week, second week, third week, fourth week, and fifth week. And give me 1 second. First week, second week, third week, fourth week, and fifth week. This is properly equal with spaces. 2, 4, 5, 4, 5 if I'm not wrong. If I would have written here also NP, would I have gotten any error? Import NumPy as Rudra. Can I do this? df equals to pd.dataframe. Do you understand what is this data frame? Like how do you actually implement a data frame? So you can say things like week, right? Week or weeks, anything is fine. And you can pass something called week data. Okay. And you can take up another variable called sales and you can take up sales data. Yeah. Is this clear? This is the data. So when we practically took the part, do we have the same exact data? Okay. From this, in machine learning, don't we divide our algorithm into two parts? Suppose I have a weekly data and I have a sales data. Won't I divide this into X and Y? Y is my target and X is all my independent variable. X can be equal to, what can I say? df of, right? X equals to df of, I want weeks, right? So I will say X is weeks, right? And I can even take values, like all the values of the data, values. Yeah, this is my X value. What could be my Y value? My Y value could be sales. So if I run this and print X, not small, but the capital one. This is my X and this is my Y. Can you see that I've taken two data, X and Y separately? When I was doing something manually, what was the first thing that I did in linear regression? Do you remember I told you, whenever you have a linear regression, you first need to calculate the mean of X and mean of Y so that you know where you want to pass from? Yes or no? So let's calculate it. Mean of X equals to and mean of Y equals to. So if I want to calculate the mean of X, can I not say NP dot mean of X and NP dot mean of Y? And if I calculate print mean of X and mean of Y is 3 and 4. This is basically all my mean values of X and Y, basically, right? I just wanted to print it, didn't want to take it. I'll take another variable called N equals to length of all the variables X. So how much data set do we have? What is the sample size do we have? 5 is the sample size. Okay. Now, what was the formula that we calculated in the machine learning class? What was the formula? Hold on, give me 1 second. Let me try to find that number that we did. To calculate linear regression, yeah, to calculate the value of M1 and X1, Did we take x minus x bar into y minus y bar by x minus x bar the whole square? And to calculate y, then we used that equation to calculate it. So x minus x bar into y minus y bar by x minus x bar the whole square. If I want to write this in mathematics, can I say numerator equals to 0 and denominator equals to 0? This is like assigning the value. And now I will loop for I in range of the total sample size, which is n. Numerator plus equal to, now tell me one thing, each value of x, x minus x bar, which is each value of x minus its mean into each value of y minus its mean. Yes or no? Each value of x, independent value of x minus its mean into y independent minus its mean. So can I write it something like this? X of I, because I will loop, minus mean of x into y of I, independent values of y minus mean of y. Can I do this? X minus x bar into y minus y bar. This will be my numerator. And I can take something called denominator, right? So denominator plus equal to, I'm also calculating for that. What is the value of denominator? X minus x bar the whole square, which is basically x of I minus mean of x the whole square. Yes or no? This completes my calculation for my m value. You remember m value? So if you want to calculate m, the value of m, is it not numerator divided by denominator? And if I calculate the value of m, what value of m did we get, my people, when we calculated the value of m? 0.6. What answer did I get? Now we need to calculate the value of c. What is the formula for c? If you look very carefully, c is nothing but, see, look at this formula, okay? Listen to me very carefully. Y bar is equal to mx bar plus c. If I rearrange everything properly, isn't c equals to y bar minus mx bar? Just rearranging. Y bar, which is mean of y, minus your value of your m that you have calculated into mean of x. So if I replace that exact same equation here and call this as c, like you call this as c, right? C is equal to mean of y minus your m value multiplied by mean of x. And if I calculate c, did I get 2.2? The same exact thing that we got yesterday. So tell me one thing. Did we implement any library in this to calculate the coefficients? We did not. We didn't specifically need any library to calculate that value. We did not do that. Okay. How about we look at the data? We visualize the data. Can we do that? Let's observe how does our linear regression look like. Okay. Plus 2. Let's take a range of mean. You can call it max of x also, actually, and mean of x or min of x. Okay, min of x, max of x, min of x, np dot x, np dot min, and yeah, that could be the range. So sorry, I'm getting a call. Apologies. Yeah. Okay. Have you ever encountered a function called line space or linspace? Have you ever had the opportunity to work with this? Do you know what in NumPy this is? You guys already know this, right? M into, okay, mx plus c. So you can call it as a, can you tell me among m and c, which remains constant no matter how many variables are added? Which, see, usually this m is also called as b1 in the equation, right? Like, and this thing is also called as b0. Like b1 and b0. You guys know that this is also called b1 and b0. Like there is no confusion there, right? So if you actually think about it, right? So let's say I have written my equation called c plus, okay? Let's say c plus b naught x, which is m into x. So say m into x, or x value could be anything, but I'll just write it down here. Which equation does not change at all in mx plus c? C does not change. What happens to m? Does it change every time there is another variable added, another target variable, another independent variable added? Will you keep this in your mind while I'm doing this code? Will you keep this in mind while I'm doing this code? Okay. Okay. Tell me this. If I pass in x comma y, okay, and give it some color like hex code online, okay. Let's take like a good hex code. Let's take darker color, or maybe, yeah, let's take like this magenta pink sort of a color. Yeah, this is good. Let's copy this and paste it for this color. Yeah, this is, I think it's going to be neater, but it's okay. Label equals to regression line, actually regression line, but ठीक है. Copy this and paste it here. Yeah, I can paste this, and I can even change the line width and all of that stuff. But okay, label equals to my data. If I want to use something called line style, would you understand what line style is? Suppose if I want to implement something called line width, width is equals to 4 maybe. If I run this example, basically this is the data point that we had, and I'm basically plotting this data. So do you know that I can also do something called plot.legend, plt.legend, and I can do location equals to best, log equals to best. And if I do this, I now have, what does this line see? Initially, observe to the left. This line is regression line, red, green is the data was not there. If I comment it, run it, see my graph is not very good. But the moment I print the legend, my graph is much more neater. Clear, like see, if I want to make it alpha, for example, alpha, ALPHA, alpha equals to 2. Do you see that my line, matplotlib alpha. Okay, a matplotlib alpha plot, dot plot, dot plot. Yeah, give me 1 second. ALPHA, ALPHA. Okay, my spelling was correct then. ALPHA equals to something. What is the value? 20, yeah? Okay, okay. You're not supposed to have a, you're supposed to have a fraction values. Yeah. Do you see that my line became very light? You saw that my line, the red line became very light, right? Like, hold on, I'll show it to you. Wait. I want a jhatang red color, like a red color that should just make us feel like what are we doing in our life? Give me 1 second. Like ultra bright red I want. Hold on. Yes, let's take this. Copy and paste it here. Give me 1 second. Yeah. This is good. Okay. So if I change this 0.2 to 0.9, do you see it is ultra bright now? Full. So what I'm doing here basically is, guys, do you see that the range in the bottom, I wanted the range to be smaller. That's why what I did is I created a max range +2, min range -2. So that on the left and the right, I have ranges for the line to plot. So if I do see, look at this, +10, -10. Can you see that line is being extended and the points? This line, I want to make it bigger. That's why. Can you see the range starts at -10, range ends at +15? Do you see that the range is -10 and +15? So I wanted the range to be good. That's why I did it. Let's keep it to only 2 because that's the best one. But do you see how my data is plotted and how my first logistic regression graph is plotted? My data points, like what I'm doing here. First, we implemented the ordinary least square method. We calculated and we fit the line. Basically, this is the linear regression line that we fit using the y is equal to mx plus c that we calculated. See, I am replicating the value of C and M, whatever we calculated on top, and I'm calculating the answer correctly, directly from the value. Can we implement R square now? Do you see the R square formula that I implemented here? Y minus Y bar, Y minus Y bar minus divided by summation of Y minus Y bar the whole square. To implement R square, can I say sum of square total is equal to 0 and sum of square residuals, the one that you want to calculate, is equal to 0? Because I'm sort of creating a counter and then later update it. for I in range of how many times do you want to iterate? N times, because that is the number of samples that we have in our data. Y predicted value, all the Y pred value, the Y hat you called as C plus M into X, yes or no? Rather than calling it X like this, can I not call it X of I? Each data point. See, here you have B naught, right? Which is C plus M into X. But each value of X means each value of X of I, right? Because that's how we will be able to implement the value. So what will be sum of square total is equal to plus equal to, according to the formula, it is each value of Y minus its mean, the whole square. Yes or no? This is the formula. Sum of squared residuals plus equal to, what is sum of square residuals? Same exact thing, but here instead of instead of mean of I, we calculated with predicted, Y predicted. We just changed this with Y underscore pred and same exact whole square. Now tell me one thing, what is the formula of R square? What is the formula of R square? Look at this, look at this. 1 minus residual sum of squares, which is called sum of square residuals. See, RSS is residual sum of squares, which is sum of square residuals. It's the same thing. Divided by total sums residuals. So hold on, let's take it like this. Where is the formula? This is the formula, right? So taking this formula, can I say R square value is 1 minus sum of squared residuals divided by sum of square total. And if I print R square, what answer did we get? 0.6. Did we get the same exact answer? These are not my formulas. We are just implementing them. So are we getting the same exact output? Yes or no? We are. Okay. We have done ordinary least square method. We have fit the line equation. We've even calculated R square. Do you want to test the actual library from sklearn and see how good are we matching? Can we try that? Okay. To do that, from sklearn, okay, dot linear model, import linear regression, okay, import linear regression. But what I'm also going to do is from sklearn dot metrics import. Do you know there is something called mean square error, my people? Mean squared error. We have MSE mean square error. I told you it is a loss function. Okay. Let's do this. Can we also calculate mean square error quickly? Let's calculate it. To calculate root mean square error, can I take root mean square error is equal to 0, a counter 0, for I in range of n? यहाँ तक clear है? Okay. Root mean square error formula. Can I show you the formula for root mean square error? What is the formula? Predicted minus actual. You need to calculate predicted value minus actual value, square it and divide it by the total sample size. Each value of Y subtracted with the predicted value, whole square and divided by the sample size. So this is a very simple formula. अब इसके लिए मुझे क्या करना पड़ेगा? I need to write something called Y pred equals to, okay, यहीं से ले लेते हैं. Y pred is equal to this. Copy and paste. Y pred is equal to this much. What will I do? Root mean square error plus equal to each value of Y subtracted with Y pred and the whole square. Yes or no? Root mean square is equal to each value of Y subtracted with Y pred and the whole square. After I am done with this, what do I need to do? I need to come outside the loop because I don't want it to be in the same iteration. Root mean square error is equal to np dot sqrt. I want the square root. Do you see? There's a square root here. This big square root. The entire big square root. Now, square root of what? Square root of what do I do exactly? Root mean square error divided by sample size. So root mean square error is how much, guys? 0.7, approximately 0.7. See, we print the value right in front of you. If I want to implement linear regression from my library, so can I not do something called x.reshape? Okay. The reason I have to do reshape is because the problem with sklearn's packages, it does not give me array directly. The X variable, the X from data frame does not give me a array directly. So I need to convert that into an array. Okay. Regression is equal to linear regression. I'm calling linear regression. I'm passing no hyperparameters whatsoever. Regression dot fit. And I'm passing in the variable of X comma Y. Okay. Run. This tells me my linear regression has already been printed. This particular thing tells me that my linear regression has already been printed. My linear regression algorithm has run. That's what it means. So tell me one thing. What is the equation of y pred value? What is the equation of y pred? So can I say y pred equals to c plus m into x? M into x. Is this my equation for y pred value? So mean square error equals to mean squared error, the one function that I've imported from top, and I'm passing y comma y underscore pred. Y underscore pred. The same exact equation that I've done. Okay. And let's also take r square. Score equals to, you can just say reg dot score, which is the same function that we've just implemented, pass comma x and y. Okay. Just x comma y. So r square score. What is the r square score we got and r square score we have from the library? Is it almost same? 0.59999, which is 0.6, which is what we calculated. Okay. How about the mean square error? The mean square error is np.sqrt of mean square error. Did we get 0.6928, 0.6928, the exact same mean square error? When we've implemented something called mean square error function C, I have imported something called mean squared error. I have called mean squared error and I got np.square root mean square error exactly the same. So there is no difference. We got the same exact fit, same exact output. We got the same exact r square and root mean square error values. You got the concept, my people. It's just the formulas converted back into the code. That's all I'm doing. I'm not doing anything fancy, right? I have just implemented root mean square error from code, and then I'm using the same exact line. It's just that the number of lines are lesser for implementing the package versus I had to write a longer code. How good is your pandas? Do you know why do you have to reshape? Kernel, restart and clear output. I have cleared my kernel, okay? My kernel is dead. I've created it from scratch. 1, 2. This is my data. I'm coming directly to here, okay? Is it giving me an error? Acha, where is X? Acha, we did not define X, right? Yeah, just 1 second. 1, 2, 3, 4. X and Y. X और Y. हाँ, ये print कर दिया हमने. ठीक है? हम यहाँ पे आए. हमने इसको रन किया, इसको रन किया. N कहाँ पे भाई? अच्छा, length of N भी बताया था ना कहीं पे मैंने. हाँ, चलो. N is equal to length of X. ये भी ले लेते हैं. 1, 2, 3. X, Y. इसके नीचे ले लेते हैं length of X. इसको वापस रन करते हैं लेंथ ऑफ एक्स के साथ एंड लेट्स रन लीनियर रिग्रेशन वाला पार्ट एंड डू इट एंड रीशेप नहीं करना है, सॉरी, लेट्स जस्ट टेक इट एक्स एज इट इज, राइट? सो एक्स को एज इट इज लेंगे हम एंड कर्नल रीस्टार्ट एंड क्लियर आउट. ठीक है, रीस्टार्ट एंड क्लियर आउटपुट. कर्नल मैंने वापस रीइनिशिएट किया 1, 2, 3, 4, 5 n and all the way from this and this. अच्छा, tell me one thing. The x variable that you just see here, the x variable that you see here, ये array में इसने इसको convert कर दिया. Not always this x variable is converted into an array. मैं आपको output दिखाता हूँ इसका. Am I getting an error saying that your array is not of proper shape? बहुत ध्यान से सुनना, okay? Listen to me very carefully. Whenever you pass a data in a linear regression model, it needs to be a nested array. एक अरे के अंदर जो अरे होती है. हैव यू एवर सीन इट इन पाइथन दैट यू नीड टू पास समथिंग लाइक दिस? माय नेम इज रुद्र एंड देन अनदर अरे कॉल्ड अलंकार. This is how a linear regression model or any machine learning model expects. But what it gives is this. Alankar. So guys, how do you find linear regression so far? The programs that I showed you right now, the programs and all the problems I showed you right now was just a warm-up. Can we actually implement a linear regression on an actual data and show you? Can we actually run regression on a real life scenario, and then let's see what we can do with that. Can we do it? Import pandas as PD. Data equals to np.read CSV. Okay, READ, read. See, even we are foolish. People like me. People call me as somebody who has good knowledge. Data.head of 4. You have a gender. 1 means male, 0 means female. Your age range, 1 means greater than 30, 0 less than 30. What is your head size and what is the brain weight? If I want to drop gender and age, it's of not important to me. If I tell you my head size, can you predict my brain weight? Can we make this linear regression model? I want to understand if I give you the size of my head. Acha, tell me one thing. If I want to do that, shouldn't I not divide my data into two categories, X and Y, just like how we do it in every machine learning model? So tell me one thing. What will I do with the head data of, right? What do I keep as an X variable? What do I keep as a Y variable? What do I keep as an X variable? The head size in centimeter cube dot values. All this can be my X variable. Yes or no? I don't care about gender or age. I don't need no gender, no age. It's of not importance to me. I am taking this as my X variable. What will be my Y variable, my people? What will be my Y variable? Brain weight in grams. Before I run a linear regression model, what did I tell you to first validate in a linear regression model? What did I tell you? You should always validate. Import matplotlib.pyplot as PLT. Did I not tell you to check linearity first? Yes or no? So can I say plot.scatter of x comma y, okay, x comma y, and run it? Does it not look like it is possible through linear regression because a line can be passed through them? It's not curvy. Make sense? I have just plotted the data and I've shown you that. But what do you need to do with the x? You need to reshape it. Yes, you can reshape it -1, 1 also, n, 1 also, whatever you want to do. It's up to you. Yes or no? Pehle ye batao. Am I saying the right thing or am I saying the nonsense things? I want to run linear regression. Have I imported all the packages properly in linear regression? How do you call linear regression? From sklearn dot linear model, import linear regression. इतना समझ में आ गया आपको? You have to remember this. From sklearn dot metrics. What do I want to import? Two things. Import mean squared error, and R square error, which is R2 score. Basically, आप उसको एक ही चीज बोल सकते हो. And from sklearn dot, you must have not heard of this, but this is called model selection. Import beautiful thing called train test split. This will become your life. If you don't do train test split, you can't do machine learning. I'm telling you this right now. Whenever we run machine learning models, don't we split the data into 4 categories? Suppose this is my head, kya tha ye? Head size and brain weight. हाँ. I have a column called head size and brain weight. अब एक बात बताओ, head size और brain weight में हम क्या ले रहे हैं? Head size is X, right? Brain weight is Y. Yes. We have split the data into 2 parts, X and Y. We've done this, see, X and Y. Here the splitting happened. But guess what, my people? You even need to split this data into train and test. Are you clear? You need to split this data into training data and testing data. Don't your machine learning model need some training? After the training is done, you need to test on the test data. So you need to split this data as train and test. X train, X test, Y train, Y test. So you will get X train, X test, Y train, Y test. This concept in machine learning will never leave you. I'm telling you, this is needed. So tell me one thing. This should happen. Yes, and this should happen in a sequence. Can I take it? X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test. X train, X test, Y train, Y test. Who do you call train test split? What will you pass the data? X, comma, Y, comma, test size. How much do you want your test percentage to be? Let's keep it 20%. So 0.2. My training data is 80%. My testing data is 20%. Linear regression equals to call linear regression just directly. Linear regression, make it callable. Simple. What do you do later on? LR dot fit. That's it. Linear regression dot fit. Pass X train, comma Y train. Any confusion? You run this. My linear regression model has run. Mera model run kar gaya. My model has run. My head size is 4,512, 3,738, 4,261, 3,771, whatever the value is, whatever the value that you want to predict. Can I help you understand how to predict? Can I show you a prediction right in front of you right now? How to predict? LR dot predict. I told you, how should you pass the data? Nested list or not? Can you give me a random number between 4,000 and 3,000? Some number? 3,000. Can we take 3,004? Okay, 3,788. What did it tell me? The weight of the brain will be? What is the prediction it gave me? It says that for a weight of head size of 3,788, your brain weight will be 1,317. Did we get the output the way we expected? And see, the output is correct. For 3,000, approximately 400 something range, we are getting 1,297 as the brain weight. So this is approximately doing a good job. What? Did you just predict? Now, let's calculate mean square error. Can we? Can we calculate R square mean square error just to know how good are we performing? So y underscore pred equals to, what is the equation? LR dot predict for all the values of X test. For all my test functions, my Y predicted values are calculated. The values that are there in my test set, all the values for test set that I have calculated, I have. The predicted values that I have. How do you calculate mean square error? Mean square error equals to, call mean square error. What will you pass inside it? Y test, Y pred. And remember one thing, this will never change. This will remain, this Y test, Y pred will remain Y test, Y pred for all algorithms in the world. I'm not changing it according to what I am doing, okay? Root mean square error is equal to np.sqrt of sqrt of mean square error. Can I say this is true? R square is equal to R2 score of, what do you pass? Y test, Y pred. Whenever you want to test something, you pass Y test, Y pred. That's it. You're done. Sorted. Can I print the values? Print f of root mean square error value is, how much is the root mean square error value? Root mean square error value slash n. What is my R square value? Sorry, R square value is R square value. Okay, R2 value. If I run this, do you see that my root mean square error and my R square value is close to 1? It's close to 1. That means the model has done a good fit. You can even plot it. We can even plot the data. Hold on. Plot.scatter. What will you pass inside the scatter plot? X test and Y test, right? Because we're doing it on the test. Yes or no? Are you understanding the logic, my people? COLOR is equal to black. Let's take it very simple. I'm not going to do very complicated stuff. I'm just taking it in a very simplistic sense, okay? And you pass in the Y pred values, and you can take the color equals to red. Label equals to data. ठीक है? और label equals to क्या है ये? This is line. हाँ, okay. Do you see how a data runs? We have fit, how good we fit the data. See, it's going exactly in a way which is fitting the data approximately well. We can increase this better. We can make it more better. We will talk about that later. But do you see any difference in how practically we've implemented a linear regression model? We got the R square value. We've just implemented it on a practical data set. I showed you how to download the data, upload the data basically to Jupyter Notebook, how to plot it, check for linearity, run it. That's it. It's no magic. There is nothing fancy that I'm doing that you're doing different. I would have done the same value, the same thing. You need to do it exactly in the same way. In logistic regression, we are not fitting a line, but we are fitting something called as a curve or called as a squiggle. That is nothing but 1 by 1 plus e to the power of minus z. This z is nothing but m1 x1 plus m2 x2 plus c. Does this make sense? Does this make sense? That we have a line equation. Initially, the logistic regression data might look like this, right? The data looks like this. Now a line cannot fit into it. So what do? I convert that all the entire line into positive and negative infinities. I fit a line. All the data points fall into the same line, right? And that, what do we do? 1 by 1 plus e to the power of minus z we apply. What happens? A squiggle is fit that fits all the data point properly. Yeah, this is the flow of the logistic regression code or algorithm. Not a very complicated thing. But now, let's look at it practically. Shall we? Can we look at logistic regression program practically? How does it work? Okay. Before I actually do that, point number one, I have a couple of questions I want to ask you. They say, right, before jumping into, it took me 2 months to even start punching the bag. For the first 2 months, they made me do workouts, which was uh, all warm-ups. For 2 months, I was dying to make my first punch on a punching bag, but that never happened. The reason is you have to first get your headspace clear before you jump into the actual stuff. You guys tell me one thing and tell me one thing very clearly. In logistic regression, okay, or any machine learning problem that you're ever going to get in any organization, tell me, will you not do this in your practical career that whenever you have a data on and the problem statement is either classification or regression, first you need to understand whether my problem statement is a classification problem or a regression problem. Example, it's a classification problem. So for the same data, won't you apply multiple algorithms at the same time? You will apply logistic regression also. You will apply support vector machine also. You will apply XGBoost also, decision tree also, random forest also. Suppose you've implemented all these algorithms, won't then you decide which algorithm is performing best and select that one? This is how the industry works. This is the reality of the industry. You as a data scientist will be given a data. Correct? You're not going to apply one algorithm one, then second algorithm second time, then third algorithm third time. You don't have enough time like that. You have one data set. You apply all the algorithms at the same time, which you think are good, and select the best one out of them. But how do you decide which one is best? Support linear regression, sorry, logistic is best, support vector machine is best, XGBoost is best. How do you finalize? Don't you need some kind of an evaluation? Don't you need some kind of an evaluation? Oh, yeah, I think this is good. But what? Do you prefer accuracy score, F1 score, AUC ROC score? We don't know. You don't know. So let me tell you one thing, guys. In linear regression, we decide the model is performing best on terms of root mean square error. If my root mean square error is lower, I'm saying it is good. But in logistic regression, specifically classification, there is a concept called confusion matrix. How many of you know what is confusion matrix? Let me help you understand. Now listen to me very carefully. Imagine there are two actors in a movie. I am about to play a movie in front of you. There are two actors. Actors are very simple. One is a doctor, other is a patient. Okay? One is a doctor, other is a patient. Imagine a girl walks into a clinic. This girl is actually pregnant. In reality, in truth, in all the truthness, she's pregnant. The doctor says, hey, my diagnosis is you're pregnant. So is this a good thing the model did? This is a good thing the model did, right? Or the doctor did. Forget model, doctor. The girl had a reality. The doctor also said the same thing, the same reality. The both sentences are true. The girl was pregnant. The doctor says, yes, the diagnosis is you're pregnant. In machine learning, In specifically classification problem, this is called as true positive. When something was really true, you predicted it to be true. Good thing. The girl in reality is not pregnant. She's not. The doctor says, don't worry, you're not pregnant, you're not carrying. Isn't this also a good thing? The top example was a positive example, but the bottom example is a negative example. She is not, the doctor says, don't worry, you're not. Isn't this also a great thing that the model does or the doctor did? This is called true negative. So true positive and true negative are all the labels which were predicted correctly. Yes or no? If something was 1, my prediction is 1. This is called true positive. If something was 0, I predicted it 0. This is true negative. So tell me one thing. Higher the true positives and true negatives, better is the model's performance. Yes or no? But where do we go wrong? Where do we mess up? We mess up in type 1 and type 2 error. Example. A guy walks into a clinic. This guy is, of course, not pregnant, correct? But what does the doctor predict? Hey, you are pregnant. The reality is the guy is not pregnant, but the doctor's diagnosis is you're pregnant. Isn't it the reverse case? When the guy is not pregnant, the prediction says you are pregnant. Isn't this what we call false positive? Did that make sense? You were not 0, but you were predicted 1. 0 and 1 opposite cases. Ulta 0 ko 0 hona chahiye tha, but 0 is 1. Not good. This is called false positive. This is what we called as a type 1 error in the program. What do we call this? Type 1 error. False positive error. It's also called as false positive error. Are you clear? Very nice. What happens in the other scenario? The girl is actually pregnant, but the doctor says, no, you are not pregnant. Isn't this also the reverse case? The girl is label number 1. Your prediction is label number 0. Opposite case. Isn't this false negative? Yes or no? So tell me one thing. I have a question to ask you. Imagine you have a 300 data set data. 300 data set data. If you want to write confusion matrix, if you want to write real, that is correct. That is correct. Did you understand the concept of false positive, true negative, false positive, and false negative? Did you guys get the concept of what confusion matrix does? Can I show you guys an example of confusion matrix? Let me show you an example of confusion matrix. Now listen to me very carefully because you're gonna love this fact. Okay, give me 1 second. Copy image and paste. Give me 1 second. Yeah. Look at this particular graph. Okay. Do you see actual versus predicted? Can you see this? Actual versus predicted. This is actual. This is predicted. Yes. Can you see? This is an actual no. Matlab 0. Actual yes meaning 1. Actual no meaning 0. Actual yes meaning 1. What is 50 plus 5? 55. Can you see downright? If you sum them, 50 plus 5 is 55. 100 plus 10 is 110. Now add them sidewise. 50 plus 10 is 60. 100 plus 5 is 105. Let me tell you one thing. In confusion matrix, there are certain things you need to know. If you add 50 plus 10 plus 5 plus 100, all 4 values will be the total data set size. Try adding it. What is 50 plus 100? 150. Plus 10, 160. Plus 5, 165. Did you get it? If you add all the values of true positive, true negative together, that is the actual size of the data. In this part, what did the model do correct? See, no ko no bola, so this is good. Yes ko yes bola, so this is good. No ko yes bol diya, this is bad. Yes ko no bol diya, this is bad. This is where your model is doing bad. Are you clear? But this is where your model is doing super good. This is how you evaluate the model. Now, let's learn something super critical. True positive, true negative, false positive, false negative. True positive by true positive plus false positive. If you come down like this, TP by TP plus FP, that is called as what? Precision. How precise was your algorithm? How good, how precision, how much precision your algorithm had? Okay. You have also something called recall. Do you see this? TP by TP plus Fn, TP by TP plus Fn. Can you see this? TP divided by TP plus Fn. Do you see this? It's called sensitivity. People call it recall also. Do you see this? TP by TP plus Fn. Actual versus predicted. Yes, that's correct. How many actuals are actually actual? Only the true positive are actual actuals, right? The one that were true, I predicted it true. False positive is the positive ones, but are wrongly positive. They are not true positives. They are falsely positive. Yes or no? Imagine from the 300 data set, from the data set of 300, you predicted 190 correctly. All the 190 truths were predicted truths correctly by you. Okay. Divided by this 190 plus what are the other wrong ones you predicted as false, predicted as true, galat say maybe 20 more. Do you understand when you divide the actual value by the total value, you get a probability value, a percentage number? Does that make sense? The actual ones divided by the actual and the false, all the total, मेरे को नहीं फर्क पड़ता है false है correct है नहीं है, but the total one that you divide, that you get a probability value, that overall how good you did with positive numbers only. All the positives were how much percent positive? Did that make sense? Every formula that you see here, precision, accuracy, specificity, sensitivity, recall, they are all very logical. If you just sit and listen, if you look at the code, everything will start making sense. There is two more metric that you need to understand. One is called Cohen's kappa. Ignore Cohen's kappa for now. Let me tell you what AUC ROC is. Do you see this curve, this graph? In classification, whenever you want to show your output to the management, will the management understand all the mathematics, precision, recall, true positive, true negative? Will they understand? People who've done MBA, people who are CEO, CTO kind of people, they only care about business. They don't care about technology. So tell me one thing, will they listen to you? When you say, sir, I got a Cohen's kappa score of 0.86, he's like, so one of the biggest problems we data scientists face is also to make sure to convert a technical concept into a very simple concept and tell them, we are choosing this algorithm because it is performing best. To help your life make much more easier is a concept called AUC ROC. Okay. We need to present that topic to the remember one thing, and this is your interview question. I can tell you with a 110% guarantee AUC ROC is going to be asked in any classification problem. Aapko logistic regression they will ask. I don't care what classification they will ask. They will ask you what is precision, what is recall, uska formula पूछेंगे, what is AUC ROC. ये question तो 100% guaranteed है, and this question is also relevant to your practical life. See, my people, AOC ROC score is a very simple score. You have a false positive rate and a true positive rate. False positive rate is a formula. Okay, let me false positive rate. Do you see this formula? False positive rate is false positive by false positive plus true negative. FP by FP plus TN. This is a false positive rate. Now, what they do is basically they plot false positive rate divided by true positive rate. We will get this lines, we will get these algorithms. Imagine you've implemented multiple algorithms, okay? Whichever algorithm, can you see this red dotted line? The red line, the dotted line, red. This is called as a random classifier. It means even if you close your eyes and select randomly, this will be the best output you will get, this random line. From this line, from this red line, how much ever farther your algorithm is in curve, that is the best algorithm. Suppose you implemented algorithm called logistic regression, support vector machine, and XGBoost. If your logistic regression curve is the farthest from this thing, you are proving once with accuracy you've proved, but again, you're proving with a graph that this is the best that the algorithm can do. This is the best algorithm among all algorithms. Nothing is higher or lower. Can you see the area it is covering is higher than all other areas? See, the algorithm that is farthest from this red dotted line, the algorithm which is farthest from this red dotted line, won't the farthest algorithm cover the highest area? That's why it's called area under curve. So the farther the algorithm is, the more area it covers, the better precision, recall, true positive, true negative it has. The better confusion matrix this algorithm had. That is what it proves. What does a random classifier means? Random classifier means one को randomly 0 या 1 डाल देना. Randomly. If a true label is 1, randomly putting a 0 or 1 using a random function. That is called random classifier. Can we jump into some practical aspect? In order for us to even jump into the practical example, what do we do good, or what do we do first that we even start doing something? What do we do for that? Don't we import some libraries? Like for example, import pandas as PD. We also do matplotlib. Import matplotlib dot pyplot as, yes or no? I've imported all the relevant packages that I needed. I have a very awesome data set. It's called HR data set. Okay. I'm going to show you how this data set is. Can you see this thing called df.head of 5? Yeah. Do you see this data in front of you? I am somewhat representing an HR data, human resource data, correct? I have every employee's satisfaction level, the last evaluation, how much percentage he got, the number of projects the guy did, the average monthly hours he has performed, the time he spent in the company, the work accidents or any fault he left the company or not, did he get any promotion in the last 5 years, what department he worked for, and was his salary low, medium, or high. This is what the data represents, yes or no? My data represents very simple things like, Bhaiya, what is the satisfaction level of the employee? What is the last evaluation? What is the number of charges? Listen to me very carefully. Do we have the guy's name? Do we have people's name? No, it does not matter. This is what I want to tell you guys. In data science, you don't care for individual person, but collectively the results. So your name, sometimes your age won't make much of a difference. Your phone number, absolutely worthless. Okay. It's called PII. Personally identifiable information. If you work for a banking company like me, that information will not be even visible to the most senior data scientist. I have it, but some of the most senior data scientists also will not be able to see the PAN card number of the loan account holder, the PII information like Aadhaar card and all of that stuff. It is a very secure environment. You can't, look at even the client's data. So you will have such restrictions. But in this case, we don't have a restriction, and we don't even need the name. So what is the first thing that you want to do? Don't you want to know how long the data set is? How many people are we analyzing for? So when we do df.shape, what do we know? There are 10 columns and almost 15,000 people. Yes or no? Agree, disagree? If you look at this record, if you look at this data set, one thing will be amazing. Don't you think the most important part for any company is how many people left the organization, how many people are with the organization? This thing in machine learning or in actual analysis is called attrition analysis. Have you heard of it? Have you heard of it? Attrition meaning if 100 people were in a company, 100 people were in a company and 5 people left the company, attrition rate is 5%. People who left the company that year is 5%. It comes under HR analytics. So we are basically doing attrition analytics using logistic regression. So you just have to focus using logistic regression. But we will do EDA also, exploratory data analysis. We will see what the data is, how the data is. We'll try to match, we'll try to make sense of the data. यार 15,000 record एक एक देख सकते हैं क्या? Can you see all the 15,000 record at once? नहीं ना, नहीं possible है. So we'll have to see through some data visualization. Okay. Because we are doing attrition, aren't you interested how many people actually left the company? So can I say left the organization is equal to df of df dot left? मतलब जो people who've already left equal to 1. For all the people who've left 1. So I will say left dot shape. Okay. How many people have left? Did I do anything? Indexing column length is, do you know that in pandas, indexing cannot happen outside the array. Matlab, it cannot happen outside, right? It happens only inside, right? How many people actually left the company out of 15,000? 3,571 people left. That must means, just for example, I know it's a very simple math. How many people did we actually retain? So can't we say df of df dot left equals to 0? And I can say retained dot shape. Yes. So tell me one thing, 11,428 are the people. Acha, tell me one thing. Let me ask you a very basic math question. How much is the percentage of attrition rate? Itna bata do. What is the attrition rate formula? Should it be retained by left into 100, retained by total into 100, left by total into 100? How should I calculate attrition rate? Tell me that. How do I identify how much percentage people left? Attrition by total, are you sure? Number of percentage people left, shouldn't it be with respect to the total people we had? Left divided by, okay, 14,999 into 100. Is this not the formula? Oh, yeah, of course. What was the formula for left? 3571. Shouldn't this be the formula? Whenever you calculate attrition, don't you calculate attrition on overall people and not the people who left? Making sense? So tell me one thing. What is the first understanding? What is the first data analysis that you did? Hey, 23% people left the organization. 23% people left the organization. P-E-O-P-L-E, people left the organization. Left the L-E-L-E-F-T. Left the org. Left the org. What does this tell you? Point number one, it's a toxic company, leave. Agar 23% people are leaving, you should also leave, right? There's no harm in leaving. 23%, almost 1/4 people left the organization. That is your first analysis. If I write this, will you understand what I'm doing? You know, there is a clause called group by in SQL. Exactly the same happens in pandas. No difference. Same. Group by based on the categories. We have only two, 0 and 1. And I am group buying basis on the people who left. That's correct. Now see, people who left the company, did you see that they had lower satisfaction level on average? On an average, people who left the company had a lower satisfaction rate. So did we now know that people who left the company had on an average a lower satisfaction rate? So this is a good variable to look out for. The last evaluation, what they did, and the evaluation for the people are almost same. So evaluation has nothing to do with people leaving. Yes or no? Making sense? The number of projects that were given to people who left was considerably higher with the people who are not leaving. So the work stress is also adding up. The more projects we gave to the people, the more chances are they left. See, this is only 3.7 and this is only 3.8. Now, please don't be stupid and tell me, sir, only 0.10 ka farak hai na. It is a mean, it's an average. Doesn't mean ki only 0.10 काम दिया है. नहीं, ये mean है. इसका मतलब somebody got work extra harder and somebody got work extra softer. Somebody who got softer decided to stay. Somebody got more work, he left the company. So be very smart. This is dot mean. Don't look at percentage value or 0.10 value. Look at it's an average. So there will be a range. Tell me, the average monthly hour worked by the person who left is higher than person who. इसका मतलब ये है, the person who was the most worked is the person who left. They made a person work so much that he left. Isn't it a very important insight? Aren't you giving this a beautiful insight that the more overworked the people are, the more chances are they will leave? The time that they spent in the company is also higher. Can you see? The people who did not leave on an average spent only 3.3, and the people who actually left have on an average spent more time. Make sense? What about work accidents? People who left had the lowest amount of work accidents. And do you see one of the main criteria is because in the last 5 years, they were not promoted. Is it not logically making sense to you in your brain that people were not promoted? They are working extra long hours. They have had not work accidents, which is positive. They're spending more time in the company, yet their satisfaction level is low. what do you think they'll do? They'll take a thali and they will do puja of the CEO, or do you think they will drop the paper on the face and leave? Of course they will leave. But we just prove that with analytics and only one line of code. Do you see? Do you now understand? You don't need a longer code. You just need the right functions to help you understand what it is. Are you guys understanding what we did? Satisfaction levels are considerably lower for the people who left the organization. You can even write it down. See, you can write it down. Satis analysis number one, analysis. Number one, satisfaction level is low for employees who left. What is the second analysis, my people, that we can give? Number of projects were considerably higher for employees who left. Analysis number 3, average monthly hours were kitne percent higher? What is 199 divided by 207? What is that percentage? You have to tell the management percentage. You can't give numbers. Kitna percent higher hai that these guys are working? From 199 to 207, what is the difference percentage? I'm asking you. How much percentage? Let's just take, for example, maybe 5% higher. Okay, 8%. Chalo. 8% high than non-leaving or retained employees. Do you understand? You now have a percentage value. You are telling your management that bhaiya, people who are leaving are overworked 8%. Isn't that amazing? So the management knows that yaar, the amount of people who are leaving are getting overworked. 8% overwork ho raha hai, right? What is the fourth analysis? Promotion in the last 5 years were considerably higher for employees who left. Okay, for employees who left. For example, this is your analysis. You're done. Acha, now that we are done with this analysis, now I want to visualize few things. Okay, I want to visualize how certain things reacted in a certain way. What was the impact? So let's try to understand something like that. What was the impact of salary on retention? Have you heard of something called crosstab? Have you heard called something called crosstab? I want to compare the salary with the people who left, but I want to plot. But what kind of plot I want to plot? I want to plot a bar plot. अब आप एक मुझे बात बताओ, क्रॉस टैब का मतलब, the meaning of cross tab is take one data, take one column, take another column, combine the columns together and read them side by side. That's cross tab. Taking one column, taking another column and reading two columns side by side. It gives you more clarity. Now listen to me. What is the impact of salary on employee retention? We saw that, of course, satisfaction lower level hoga, people will leave. Number of projects you will give them more, people will leave. Average monthly hours they are doing more, people will leave. Promotion in the last 5 years not done, people will leave. But what about salary? Isn't that also main criteria? People who left the company. So salary is divided in 3 range, correct? High, low, and medium. Among which category of salary people left the highest? Isn't the people who had the lowest salary left the highest? Can you see this? The orange is the people who have left for the salary low. Did that make sense? People who had lower salary are the highest to leave. Aren't you going one step deeper? People who have medium salary did not leave considerably. People who have high salary, the attrition rate is the minimum there. So more money you pay, they ignore how much you're giving them projects, how much satisfaction level you have, how much work accident, how much promotion. If you give them good salary, people are usually tend to not leave. Does that make sense? Because the attrition rate in the highest salary is the lowest. And the group by that we did was a mean, right? That means this must apply to everybody, right? Average value, they are almost average, they have worked out too much, they have not been promoted. So it must also apply to the high people, right? The high salary people. But see, the attrition is rate. So that means paisa bolta hai. If you give good money, people are deciding to stay because you're paying them according to the value. Did that make sense? Now, let's do one more example. Okay, pd.crosstab. If I want to do dot plot, okay, kind equals to bar, what will this tell me, my people? Won't this tell me what department most people left in? People left, we know. But which department was the most affected department? Which department people decided to leave more? Which department did they leave more? Is it surprising for you that they left sales? Because people who work in sales know it's a very terrible job, right? Sales job has a terrible aspect to it, right? You have per month, you have a target to achieve 100 people should have been converted. You will get 5% commission on sales. So what is the first department that was the highest? Which is the lowest attrition department among all? Management. Can you see? Management. Management. Not HR. Management. Can you see? Management सबसे छोटा है. R&D and management is the lowest because that's where the pay is high. How can you do it? Can you not do PD dot cross tab of department and salary? Did you get it? If you do PD dot cross tab of department and salary, won't it tell you which department gets the highest money? So won't that give you an idea that why people are retained? Are you understanding how analysis is connected to each other? You guys got the concept of what I'm trying to say, right? Okay. From all the analysis that we've done, can I say that satisfaction level is a very important variable? Satisfaction level from the group by function was a very important variable. The average monthly hours also was an important variable that caused a change in the algorithm, that caused a change in people's perception. Okay. Can I say promotion in the last 5 years was also an important category, and salary, of course. Salary to bhaiya is the most important. So rather than taking all variables, can I just take these four variables as one of my main criteria? Okay, so let's do one thing. Let's create sub data frame. Inside this, what we'll do is first we will take something called satisfaction level. Okay, so first let's come here and let's take satisfaction level. Okay, let me copy this. Let me paste it here. Okay, I am not taking all the variables. I am only taking satisfaction level. What is the second thing that we'll take? Average monthly hours, correct? So where is average monthly hours? Average monthly hours. Okay, we will copy this and we will paste it here. After average monthly hours, what do we do? Promotions in the last 5 years that the person has gotten, right? So where is the promotion in the last 5 years? Here, we'll take promotion in the last 5 years, copy it, and we will paste it here. Promotion in the last 5 years. Which is the last variable that we will take? Salary, correct? So we will copy it like this, and we will come here and we will paste it. So what did we do now, people? What did we actually do right now? So what we've done is, rather than taking all the variables which are not important for me, I have only decided to take specifically these four variables that are resulting in the output. What is your satisfaction level? What is the average monthly hour? And what is the promotion? Everything else is just fog. It is not important for my analysis, and I'm not going to consider that. Did that make sense? Did that make sense to you? Simple as I can. Guys, let me tell you something. Do you see the same data set that you see here? The same HR analytics data set? I have taught this same data set to data scientists who come with 4 years of experience. I'm teaching it to the same, which is you guys who have very less experience in data science. I can go much more complex in this data set. There's more analysis to be drawn. But at a very simplistic level, you need to understand how you need to get started, right? I am doing this because I know. Don't you think you also need to analyze some things more that I may have missed out? I have missed out so much more. Actually, department wise bhi maine calculate nahi kiya hai. You need to do that on your own, but do that. Now tell me one thing. Can I feed this data directly into the machine learning code? Can I feed this data directly into the machine learning code? Can I just like put this in, push it in, and our answer will come? Why? Why can't I do it? Which column is going to cause me problems if I do that? Column is going to cause me problems. Salary, right? Why salary? What's salary going to do that's going to cause me problem? Salary is a column which is a string type, yes or no? We call it as a text. Does computer understand text? No, sir, it does not. Don't you need to convert text into a number? Don't you need to convert a text into a number, yes or no? So tell me one thing. I am telling you to convert text into a number is a technique called encoding. What kind of encoding exists? Label encoding, target mean encoding or mean encoding. Okay. आप बोलो one hot encoding or dummy encoding. Your salary is low, medium, and high. Correct or no? If I convert or make low as 0, medium as 1, and high as 2, this is a problem. You know why this is a problem? Because machine learning will consider 0 as a lower number and 2 as a higher number. So it will give more preference to high. Agree or disagree? The weightage issue will come into picture. Yes or no? So which is the best kind of encoding? One hot encoding is the best kind of encoding. So what is low, medium, and high will become 0, 0, 1, 0, 1, 0, 1, 0, 0. In pandas, how do you do that? Okay, I'm going to write something. You will have to understand what I'm basically trying to write. Okay, in pandas, we have a function called get dummies. We have a function called get dummies. Okay, so what I'm going to do is I'm going to take the sub data frame that I've taken, all the salary that I have taken from that particular thing, because only salary needs to be converted, and I'm going to make the prefix as salary only. Okay, I'm going to keep the prefix as salary only. This code, what it does is it converts this low, medium, and high, whatever the function is, it converts that. I need to reconnect the data that I just created back into my sub data frame. So can I say df with dummies is equal to, have you heard something called pd.concat? Have you heard of something called pd.concat? Okay. Sub df salary dummies, if I take it, but once they are added, the data is ruined. Don't you think I need to make it change and say that the axis that you want to connect itself with is the columns? If I run this, what happens is if I run df with dummies, dot head, for example, just say dot head of 5. Do you see that my salary low is converted to 010 encoding? And okay, answer this to me. How good is your pandas between 0 to 5, my people? All of you in the class, how good is your pandas? Do I need to explain this code to anybody? Salary dummies, pd.get dummies, pd.contact. Get dummies is only and only converting the number low, medium, and high into encoded value. But because it is not directly added, I need to concat it. I hope you guys understood this simple logic. In PD, didn't we have a function called pd.concat? But pd.concat do not add row wise. It adds column, it does not add column wise. It adds row wise. You remember? pd.concat function adds row by row, not column by column. It made sense. That is why 010 for low is coming. Can you see low is 010? Our data set is prepared, but there is still one problem. What is that problem? df with dummies dot. What do I need to drop from this? I don't need anymore. What do I need to drop from this? I don't need anymore. Isn't it salary? Isn't it salary? Axis equals to columns. Or you can also write it once. Does that make sense? Does that make sense? In place equals to true. Okay. df with dummies dot head of 5. Dot head of 5. What did I do wrong? What did I do wrong here? What did I wrong here? Jupyter Notebook has a cache. You remember, right? Tables are all cached in each columns. You need to rerun it once again to set everything so that the cache is updated. You can't run the table again and again. Are you clear, right? Like once you do df.drop, it is dropped. If you go from top only, then it will come back again and drop again. I hope you know this in Jupyter Notebook. If you drop something in the column and that operation ran, you can't drop it again. See, if I run it again, is it not giving me error? Because it is already dropped. The cache is already done. You got the concept. Once you drop something, there is nothing to drop. So if you run the cell again, it will give you an error. That's what I wanted to say. Anyways, yeah, no problem. Is the data clear, everybody? We have satisfaction level, average monthly level, promotion level, salary high, salary low, salary medium. Yes. Now tell me one thing. If I want to predict an algorithm, or if I want to make a prediction of the algorithm, don't you need to divide the data into X and Y different categories? X will be my target, X will be my predictor variables, and Y is my target variable. Yes or no? All the X variable is nothing but the DF with dummies. Yes or no? So if I do x dot head of 5, this is my target variable. Sorry, not target variable. This is my predictor variable. Yes or no? But what is my target? Yes or no? All the people who left, not left, people who left the company here. Can you see this variable called people who left the organization? This is my target, right? We need to predict, will the person leave or not leave? Yes or no? Will the person, given this prediction, will the person leave or not? That's what I need to predict. So isn't this going to be my y variable? And if I do y dot head, actually, I will not be able to run head in this. It's not an array. Yeah, it's not a data frame. But yeah, matlab, you guys get the idea. I've taken my segregation as my x and my y, my feature variable and my target variable, my predictors and my target, my feature and my target. Here is where the machine learning starts. From sklearn, what do I need to import first? Dot model selection, import, what am I doing? Linear regression or logistic regression? We are actually doing train test split. First, we need to split, right? X train, what do we do next? X test. What do we do next? Fast. Y train, next, Y test is equal to. What do I do here? Train test split, I call, and what do I pass inside it? X comma Y. Yes. How much test size should I keep? Let's say 20%. 20% रख लेते हैं. For from sklearn, if I want to import model, how do I import it? We did that same thing exactly in linear regression model. Dot linear model import logistic regression. Are you clear? What do we do? Model equals to call logistic regression, make it bracket because it is a callable function. We called it. Now what do we do? Model dot fit. Okay. Model dot fit. What do I need to pass? X train, comma. What do we pass in training? Y train. Yes or no? This is what we do. If we run it, did the logistic regression work? Did the logistic regression just work? I want to predict a value. I want to predict some number. Say, for example, suppose you have a function called x test. Okay. In x test, you want to take a specific number called 12 colon 13. Let's take this value. A guy whose satisfaction level is 0.61, his average monthly hour is 245. He did not get promoted. His salary is 001 category. If I want to predict for this particular value, whether he got the answer correct or not. So how did we do it? Y test of 12 colon 13. What is the output that we get here? The person has already retained. Can you see it is 0? If I want to do model.predict, what do we pass inside this? X test of this guy, 12 colon 13. Did it give the prediction 0? Actually, the guy did not leave. Our model is also predicting, bhaiya ye nahi jayega. This is what we call true negative. 0. Sahi hai na? I've shown you how to predict also in front of you. How to predict a particular category. See, I showed you what reality it was. 4191. In reality, he did not leave. 12, 13 का मतलब है 12th row and 13th row के बीच वाला, मतलब 12th row basically. See, in pandas, if you want to take certain rows, say for example, 14/15. So you see, it gave me only one. Did you get it? But if I do 18, so it will give me 2, 3, 4 actually, correct. 14 से लेके 18 तक के सारे दे दिए. From the test set only I have taken the data. I have not created the data on my own. गलत हो जाता. You got it? So if I exclude 18, it will give me all from 14 onwards. If I just take 14, it will give me everything from 14 to the last. Okay. So anyways, just for simplicity reasons, I wanted to teach you this, that see, the model is doing as it's supposed to, right? There will be some true positives, some true negatives, right? That's what we want to predict. That's what we want to get an output for. We need to understand what did our model do good. Now, to get the model accuracy, don't you need to do something called model.score? And tell me one thing, do you need to calculate the true positive, true negative yourself, or the code will do it for you? The code will take care of that for you, right? You don't have to do it. What is the accuracy that we got in our model? Our model is 77% accurate. From all the 15,000 records, 77% of the record positive or negative, I am able to predict. Agree, disagree, my people? Now tell me one thing. Have you seen an accuracy matrix here? The one that I used to tell you, uh, that confusion matrix. Have I plotted that yet at all? Have I plotted AUCRC score? Yeah. So do you think our job is done? No. You need to create another column, another thing called ypred, and that is model.predict. Okay. Model.predict. What do you need to pass inside this? All the X test value, right? The ones that are actually to be frankly predicted, zeros and ones, we need to now categorize. From sklearn, dot, does classification not come under matrix? So we have to use something called matrix. Import, use something called classification report. What will you use? Classification report. Specifically start using something called classification report. Just say print classification report of what do you pass when you want to test something? Y test, ypred. Remember one thing. Y test, comma, ypred. If I run this, did we get a precision, recall, and average value? Do you see 79% precision I'm getting in calculating 0 and 0 properly? And 1 is lower. Can you see? All the people who are categorized left, my precision is lesser in that. My recall is much worse in 1. You thought 77% came, so my algorithm is performing well. But is it? Is it? No. Do you see? You have two categories, right? 0 and 1. You need to do a good job in 1 also, right? दोनों में अच्छा करना है, not in 1. Are you understanding me? Let me give you an example. Imagine you're a good husband or a good boyfriend or a good brother. To be a good brother, you need to be empathetic and you need to be kind, but you also need to be very strict, right? You're only and only kind. You're not strict. You don't have empathy. 100% kind you are, but that doesn't mean it's your overall 100%. Only one category or 100%. All three you need to be good at, right? Empathy also, kindness also, but a little strict also. All three. Your classification model gave us 77% accuracy, but that accuracy is only in calculating the people who left. We are very bad, or the algorithm performs very bad in calculating people who've already left or will leave. Yes or no? Can you see our precision is also small? Recall is also small. Does that make sense? Does that make sense, my people? Sometimes what happens, one category is so confident that it undermines the other category. You need to make sure both categories are important for you. Does that make sense, my people? Did that make sense to you? Both the categories are important for you and you need to give equal category, equal importance. Okay. I have a small question I want to ask you. Can I? To test your skills. In medical industry or in medical science, is type 1 error more important or type 2 error more important? In medical science, is type 1 important or type 2 more important? Who do they give more focus on? It's the type 2. You know why? Let me tell you. This is actual, this is patient, this is actual, this is patient, this is actual, this is patient, this is actual, this is patient. Not sorry. Doctor, patient, doctor, patient, doctor, patient. Okay. A guy has cancer. Patient also has cancer. Doctor says you have cancer. Did you save this guy's life? True positive? Yes or no? The guy does not have cancer. You predicted you do not have cancer. Did you save this guy's life? Yes, sir. True negative. You saved the person's life from mental trauma, from mental stress. You saved this person. The guy, the patient actually does not have cancer. You say you have cancer. Type 1. Did you just make his life a living hell by giving the person stress? But more than giving stress, which is actually problematic, giving harm, right? Patient says actually he has cancer. Doctor says you do not have cancer. Is not type 2 error much worse? So tell me one thing, whenever you're doing classification problem, is 0 more important to you or 1 more important to you? Which is more important to you? That depends on your data. In our data, people who are leaving, to identify them correctly is more important than the people who are retained. Yes or no? Did that make logical sense to you? To my logic, I wanted to predict people who are retaining or people who are leaving. I want numbers to be higher and more confident there. If the numbers are terrible in the 0, I am okay. It's okay. I don't want that high answer in the 0, but I want high predict and possibility in the 1. Did you understand? Category wise also you can change the algorithm to give you better output. You are my students, my people. You go to a job, your manager should be impressed by you, that how deeply this person is observing. And this is how you're supposed to professionally work. In our case, can we say we built a successful model? No, no. 77% accuracy means nothing. कुछ भी नहीं है. When the actual data point that we want to predict, which is important to us, aren't people who are living catching that more important than people who are not living? So categorizing one is more important, but you see the precision is also bad. Recall is also bad. And you know what? This accuracy is not supposed to be seen. You're supposed to see the macro average. What average are we getting? 59%. Did you get it? We are getting a 59% of macro average percentage of the classification algorithm. Are you clear, my people? My AUC ROC graph and then move forward. ये जो macro average है, don't learn about it now. I am telling you guys, you will get confused. Don't give a single anything when you want to do this. Just know that macro average is a much more true reading. Don't care what it is now. Don't read about it now. Macro average hai. Can we see how AUC ROC is performing? Okay. From sklearn, okay, dot metrics, I want to import something called ROC AUC score. Okay. It's called ROC AUC score. अब आपको समझ में आएगा. You will understand the meaning. Again from sklearn.metrics. Okay. sklearn.metrics. You can import ROC curve directly also here. Comma करके. Comma ROC curve. Because you see, I'm importing from both sklearn.metrics only. You can do it like me. I do it because I like my code to be readable. Do you understand? Whenever I write code, my people, I have a habit. I always write my code in such a way that people are able to read it easily. That's why my codes are a little longer, but they're easier to read. Okay. I'm going to say logit ROC AUC. Okay. Just because we are using logistic regression. So I'm calculating the logistic regression's ROC AUC curve. Did you understand the full form of ROC AUC score? This is called receiver operating characteristics and area under the curve. That's the same thing. Okay. I'm going to pass in white test, ypred. Do you remember I told you that whenever you calculate something, you pass in white test, ypred? Same thing. Can you see this? Ypred model dot predict x test. Rather than calling it ypred, I can even pass it like this. It's basically y test, ypred, nothing else. See, this is y test and that is ypred. Model dot predict all the x values of test. Rather than calling it like this, let me call it like this. False positive rate, true positive rate. Okay, false positive rate, true positive rate. And there is also something called thresholds. Okay, or you can even write it thresh. Okay. Thresholds basically help you calculate. Whenever you calculate AUC ROC score, it calculates multiple confusion matrices, right? So we call it ROC curve of passing the value of y test, same exact thing. What do you think you need to pass next to it? Model.predict x test. Actually, here you will pass something called predict proba. It's called predict probability. Here, what you're doing is you're passing all the x test value, okay, which is this. But do you know in logistic regression, we calculate something with a threshold? If more than 50% one, less than 50% zero, we have a threshold set, like, for example, something like if it is up to 50%, less than 50% zero, up to 50% one. Don't we work on that categorization? By default, have I passed any probability to the logistic regression function? 50% ke above 1, ke lesser 0. Did I pass it here? We did not. So what it did is it automatically calculated a probability by itself and it added. But shouldn't we add it ourselves and make the algorithm tweak better? And that is how we will make this one perform better, to tweak the probabilities. That maybe 80 ke upar say 1, less than 80 say 0. Make sense? The false positive rate, the true positive rate, all of that. How many of you actually love matplotlib, guys? You guys have actually worked on matplotlib. You guys actually love it. Actually understood what this particular value is. You guys know this, right? Okay. Have you also tried? Have you also tried something called now? Imagine I want to draw a vertical line. How do I do that in Matplotlib? I have a graph. I want to plot like a vertical line. How do I do that? Where do I start? What is this called as? Is it called 1, 0 or 0, 1? If I write it like this, will you understand? Comma, from 0 to 1 to 0 to 1. And I want it to be all dashed. So you can give it like a dashed line. So something like read line dash dash. So do you understand that I'm getting like a dash dash line? Like you can also make it diamond, but like you get it, right? The dash 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 line that you get. Do you see how our logistic regression is performing? Is it beyond the dash line? Is it beyond the dash line? Is it better than a random classifier? 100%. Do I have any other algorithm I can compare it with? No. But this is my AUC ROC score. The farther it is from the line, the better it is considered. Yes or no? So is this not giving me an output? Now tell me one thing. I need to calculate its area. Okay. To do that, write it here like this. Area equals to, do you know, I can write float point values like this, 0.2f like this. If I run this, is it giving me any output here? Is it giving me any output? No. Plot.legend, legend and location equals to best. If I run this, how much area it is covering? 60% of the area. Did you get it? See, 0.59. The area this graph is covering is about 60%. Did you get it? We always prefer the graph with a higher area. I just calculated and show you how to calculate area also. Right there, simple. Did that make sense? See, I've passed in something called logit AUC ROC here. See, ROC AUC score mein, I have just passed in the area that it is covering. That's it. This number is the area, this 0.59. That's what it is. Did you understand? And you know what? No matter what algorithm you implement, the code for AUC ROC will never change. If you take my code, this code, and apply it on any algorithm you want, you have the freedom. It will not change. Same exact code will work. Just the model will change. We just completed logistic regression. I want to show you one thing. This is called documentation. Yes or no? The company that created sklearn has a documentation on logistic regression. Inside logistic regression, what have I passed? Can you see? I have passed nothing. It is absolutely empty. Can you see? It's absolutely empty. But what options do I have? I can pass penalty. I can pass dual flag. I can pass something called C, fit intercept, solver, random state, weight, intercept scaling, worm, number of jobs, L1 ratio. Did I pass anything inside? Are you wondering why I got a bad result? Are you now understanding why we are getting terrible results? Because nothing is tuned. Did that make sense? This values that are passed inside, okay, are hyperparameters. What are they called as? Hyperparameters. Now, I also did something called crosstab. In crosstab, what I decided to do is I also wanted to know, because my common sense tells me salary is one of the biggest factors. So I did a crosstab of salary. The reason why you cannot, acha, can somebody tell me why I had to take salary separately and group by separately? Because you cannot take a mean of string value, correct? Yes or no? If your data set has a department or a column called salary, क्या आप उसका mean ले सकते हो? Can you take a mean of it? Can you do group by? Example दिखाता हूं मैं आपको. How many columns do we have? 10. Can you see 10 columns we have? If I do df.describe, and if I run this, sorry, it's a callable function. Yeah. How many columns am I only getting in the description? Can you see how many? 1, 2, 3, 4, 5, 6, 7, 8. बाकी के दो किधर गए? डिस्क्राइब में, इन्फो में आ जाएगा, डिस्क्राइब में, ग्रुप बाय में, एंड ऑल ऑफ दैट में कभी भी यू विल नेवर फाइंड अ कॉलम विद द स्ट्रिंग वैल्यू, बिकॉज उसका क्या करोगे आप? अंडरस्टूड? कैन यू सी which is the highest promotion somebody got in the last year? Somebody has gotten 100% promotion. somebody has gotten no promotion at all, ये भी हुआ है, ठीक है? The highest amount of satisfaction level somebody has recorded is 100% satisfaction level. The lowest somebody has recorded is 9%. Can you see 9%? So you can find descriptive statistics here. Min, max, standard deviation kitna hai, mean, average kitna hai, how much is the average working hour 201. There is somebody in our data who has worked 310 hours. There is somebody in the company who's worked only 96 hours. See, ye bhi difference hai. So when you do describe, you get all this information also. So that is why when I did group by, I did not have the information of salary. So salary I took using a function called crosstab. Does that make sense? I did a cross tab of salary with all the people who left because that is my aim. That is what my intention is. And I got an output which says high, low, and medium with compared to salary. Okay. PD.cross tab, administrative experience. So when we do PD.cross tab of department and the people who left, we also get how many people left department wise. That is an important analysis for us. What we realized is HR and marketing and management and R&D were some of the lowest. Some of the highest were sales, support, technical, and of course, IT. IT is IT infra. I think it is IT. Yeah, IT infra. Okay. Then after creating an understanding of all of this, what I did, I created another data frame. And in this data frame, I had satisfaction level, average monthly hours, promotion, and salary. These are important data sets. These are important features for that matter of fact. What I did from all the original features, I've taken the important features, I've kept them separate. After I've kept them separate, I have taken something called get dummies. Now, remember one thing, one hat encoding is get dummies in pandas, but you can't directly apply because they get concatenated. Row by rows, they get added. So what do you need to do? Once you create them, it creates a number called 010. For example, I should have shown you this salary dummies. Okay, notice this. Can you see it's becoming 3 separate columns? 010. It is not connected to the actual column, which is this, right? Sub df. Yes or no? This is creating a separate independent 3 columns. What do you need to do? Because these are creating 3 independent columns, I need to concat with the sub df at salary dummies, but I want it access not to be row, but columns. So now rather than getting added left by left, it gets added row by row. So basically column wise it gets added because access equals to columns. You can even replace this with 1 or 0. 1 is column, 0 is row. What I did after that is I have taken a separate data frame called df with dummies. From df with dummies, I decided to drop my salary because salary is still a string character. Once everything is said, this is my feature, left or not is my target. The most easiest thing, I've imported train test split, I've imported logistic regression, I fit my model, and I've even taken a record and did model.predict on it. I got a right output on that. The biggest change in the code is at this part. Okay, now let me please allow me to explain something here. Guys, you must have heard of something called model.predict. Koi bhi, it's not a very complicated thing. You must have not heard of something called model.predict probability. Tell me one thing. When you use model.predict, do you not get the output whether it could be 0 or 1? Yes or no? Agree or disagree? But when you do model.predict probability, it does not return 0 or 1. It returns the probability. Then based on that probability, you can decide output will be 0 or 1. Are you clear? This predict probability function prints all the probabilities it has. Suppose for line number 1. Guys, do you remember I did this model.predict for 12,13? Then I got the output 0. Okay, look at this. Model.predict probability for X test 12,13. What answer did I get? Do you see I am getting probabilities and not the actual output? This is the probability. This is the count threshold. Let's ignore that. Did you get, we got 80% probability that something is 0 or something is 1. Favorable, not favorable. Yes. You guys got the concept, right? Model.predict returns the output. Probability lets you play around with the probability. Whether you want the threshold to be 50%, 60%, 80%, you can change it. If I do 0, is it returning the probability to me? Can I say if model.predict probability is less than or equal to 60 or greater than or equal to 60, what do? Print I am 1, else print 0. Can I even do this? You got what I'm trying to say? You can tweak the probabilities like that you can set up a threshold like this. Now, what I do is I print another variable called false positive rate, true positive rate, and threshold. If I run FPR, okay, or if I say print, I will say print FPR /n TPR /n and thresholds. Okay. Let me basically copy this and paste it here. Did I write /n wrong? Yeah, I got it, right? What is the length of this? Hold on, let's first calculate the length. Then we will know if we got the FPR correctly. 992, ठीक है, okay. Comma, true positive rate, okay. And let me also say thresholds, okay. So false positive rate aa gaya, true positive rate aa gaya, and all the thresholds have also been printed, okay. My people, let me explain what this is, okay. To draw a graph, to plot a graph, to plot an AUC ROC graph, suppose if you want to plot it like this, suppose this is my graph, okay? I want to plot it like this. Don't you think for every line you need a point? Did you get it? Like you need a point in every line. This entire line is of 992 points. And what I did is I connected the lines. Does it start forming like a ROC curve? Did you understand what it is doing? It's calculating AOC, ROC points for X, Y, X, Y, X, Y. See, this is TPR, this is FPR. Let me remove threshold, okay? Let me remove threshold. This is true positive rate versus false positive rate. So 0, 0. Okay, you see down at the bottom. Yeah, 0, 0 point, 0, 0, then 0, 0.00 something. Are you understanding? Each row is corresponding to its each point, and that's what we are plotting, isn't it? See, this is what we are plotting. Yes or no? Let me comment it out. Do you see that point itself becomes like an ROC curve, and we take the area under them. I hope that makes sense. That's what I'm doing. What about the red line? See, red line is considered the baseline. Do you see 0, 1, 0, 1 here? This represents diagonality in matplotlib. If you don't know, here is how you represent 0, 1. In a number line, what is 0, what is 1? What comes first, X or Y? We always do X, Y, correct? So 0, 1 यहाँ होना चाहिए ना? सही है ना? According to our XY. एक diagonal को बनाने के लिए, to make a diagonal, what property do you need to have to make it diagonal? But to make a diagonal, how do you do it? How do you make a diagonal? You need an equal slope, yes or no? Start point and end point. Okay.